Have you ever imagined a place so extreme it feels like another planet? A realm where darkness is absolute, pressure could crush a human to liquid, and yet life thrives in ways that seem ripped from a sci-fi novel? Welcome to the Mariana Trench, Earth's deepest, most mysterious frontier. A place closer to the planet's core than anywhere else. Today, we're plunging into this abyss to explore its mind-blowing geology, uncover its bizarre inhabitants, and follow the daring explorers who risked it all to see it. From tectonic battles to glowing sea creatures, this is a journey into the unknown that'll leave you awestruck. So, strap into your virtual submersible, and let's dive deeper than ever before. What is the Mariana Trench? The Mariana Trench is a colossal, crescent-shaped scar in the Earth's crust, stretching 1,550 miles long and 43 miles wide in the western Pacific Ocean, near Japan, the Philippines, and the Mariana Islands. Its deepest point, the Challenger Deep, plunges nearly 7 miles, 36,200 feet below the ocean's surface. To put that in perspective, you could stack 35 Eiffel Towers or drop Mount Everest into the trench, and there'd still be over a mile of water above its peak. This isn't just a hole, it's part of a global network of ocean trenches formed by tectonic subduction, where the massive Pacific Plate is forced beneath the smaller Mariana Plate, creating a deep fracture. This collision also fuels volcanic activity, forming the Mariana Islands as molten material rises from the subducting plate, part of the Pacific Ring of Fire. The conditions are beyond comprehension. Temperatures hover at 34 degrees Fahrenheit, just above freezing, and sunlight can't penetrate, leaving total darkness. The pressure reaches 16,000 pounds per square inch. Imagine 50 jumbo jets stacked on you, enough to turn bones to jelly. Known as the Hadal Zone, named after Hades, the Greek underworld, this realm was once thought to be a lifeless void. The term Hadal reflects its hellish inaccessibility, requiring specialized technology to study. The trench's steep walls, some dropping 2 miles in a single slope, create a labyrinth of canyons and ridges, making exploration a logistical nightmare. Its isolation also makes it a natural laboratory, offering insights into Earth's geological evolution and the limits of life, from ancient microbes to modern ecosystems. The Mariana Trench's story begins in 1872 with the HMS Challenger, a British research ship on a 4-year, 70,000-mile mission to map the ocean floor, covering a third of the distance to the moon. At the time, most assumed the deep sea was a flat, lifeless expanse. The crew used a laborious method, dropping 249 miles of rope with lead weights every 140 miles to measure depth. Near Guam, 200 miles offshore, the rope kept dropping, hitting nearly 5 miles down. This spot, later named the Challenger Deep, stunned scientists, revealing a complex seafloor of peaks, valleys, and trenches. This discovery was a scientific earthquake, akin to finding mountains on a supposedly flat world, and it birthed modern oceanography. The 1940s brought sonar. Developed during World War II to hunt submarines, sonar sends sound waves that bounce off objects, returning to create 3D maps of the seafloor, a leap from ropes to high-tech precision. In 1951, a British Navy ship used sonar to map the trench's true scale. A 500-mile-long chasm, 30 times deeper than the Empire State Building is tall. These maps revealed a dynamic, mountainous seafloor, with ridges and valleys rivaling terrestrial landscapes. This sparked geopolitical interest, as navies saw strategic value in deep-sea terrain for submarine navigation. The discovery raised new questions. How did this trench form? What lived there? It set the stage for some of the boldest exploration missions in history. The desire to see the trench firsthand led to extraordinary feats. In 1960, U.S. Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Piccard squeezed into the Trieste, a submersible with a 6-foot steel sphere for a cabin, about the size of a household fridge. Descending at 3 miles per hour into pitch-black depths, they saw only bioluminescent plankton, glowing like fireflies. At 20,000 feet, a loud bang shook them. The outer viewing window cracked under pressure 1,000 times stronger than at sea level. With one pane left, they faced instant death if it failed. Yet they pressed on, reaching the Challenger Deep at 35,800 feet after nearly 5 hours. They found life. Pale, shrimp-like creatures, flounder-like fish, likely sea cucumbers as we'll see, and a brown diatomaceous ooze, a mix of microscopic algae remains, covering the seafloor. In just 20 minutes, sediment clouded their view, forcing a 9-hour round trip. Their dive proved life could survive the impossible, rewriting biology textbooks. Walsh later said the cracked window was like a gunshot, but their courage opened a new frontier. In 2012, filmmaker Filmmaker James Cameron made a solo descent in the deep-sea Challenger, reaching the bottom in 2 hours and 36 minutes. His submersible's high-definition cameras captured microbial mats, bacteria using chemosynthesis to convert seafloor chemicals into energy, like photosynthesis without sunlight. Japan's unmanned Kaiko submersible, diving to 10,897 meters in 1996, sampled bacteria thriving under extreme pressure, called obligately barophilic, which die at lower pressures. In 2019, explorer Victor Vescovo set a record dive at 35,853 feet in the limiting factor, discovering new species and plastic debris, a grim sign of human impact. Only 4 people have reached the Challenger deep, compared to 12 on the Moon, highlighting its inaccessibility. The Trieste's design was a marvel, a 50-foot hull with aviation gasoline for buoyancy, lead weights for sinking, and 5-inch thick steel walls. Cameron's and Vescovo's submersibles used syntactic foam and titanium, reflecting decades of engineering advances. Each mission cost millions, with Vescovo's program alone estimated at $50 million, showing the trench's allure and challenge. These dives also required meticulous planning, from pressure-resistant materials to life support systems, as even a small leak could be fatal. Despite crushing conditions, the Mariana Trench is a biodiversity hotspot. Xenophyophores, single-celled, sponge-like organisms, grow up to 8 inches wide, filtering nutrients from water. Amphipods, like the giant Hirondelia gigas, act as the trench's cleanup crew, eating dead fish, sunken wood, and even plastics. They extract aluminum ions from mud to form armor, protecting shells from dissolving under pressure that breaks calcium carbonate below 5,000 meters. This aluminum shield is a stunning evolutionary trick, like crafting armor from the environment. Sea cucumbers, like the sea pig with tentacle-like feeders, sift sediment for food. Higher up, bioluminescent creatures light the dark. Deep-sea dragonfish and sea devil anglerfish use glowing lures to hunt, while hatchetfish blend into faint surface light for camouflage. The Mariana snailfish, found at 8,000 meters, is the deepest known fish, named Pseudolaparus swiri, after an HMS Challenger crew member. Its gelatinous body resists pressure, but the Challenger deep's depths likely dissolve vertebrate bones, suggesting Picard's fish was a sea cucumber. Predatory tunicate sea squirts anchor to canyon walls, snapping up prey, while microbial mats drive the food web via chemosynthesis, acting as the trench's plants. Recent expeditions, like a 2020 study, found new amphipod species with enzymes that digest tough materials, hinting at vast biodiversity. The trench's isolation creates evolutionary islands, like the Galapagos, fostering unique adaptations. A 2023 study estimated 10,000-plus undiscovered species, each a potential key to understanding life's resilience. For example, xenophyophores' ability to sequester heavy metals could inspire new filtration technologies. The Mariana Trench is a geological and biological marvel. Its formation through subduction reveals how tectonic plates shape Earth, driving earthquakes and volcanism. The Mariana Arc, with over 60 volcanoes, is one of the world's most active, fueled by the subducting Pacific Plate, part of the Pacific Ring of Fire, which accounts for 75% of global volcanic activity. Its lifeforms show the limits of adaptation, offering clues about life on extreme worlds like Europa or Enceladus, where subsurface oceans may exist. NASA's astrobiologists study the trench to model extraterrestrial life, as its chemical-rich vents mirror alien ocean conditions with similar pressures and chemical gradients. Research here could transform biotechnology. Enzymes from trench bacteria, stable under extreme pressure, are being explored for drug development, biofuels, and recycling. A 2021 study found a microbe's enzyme degrades plastics 10 times faster than current methods, potentially revolutionizing waste management. The trench also holds clues to life's origins, as its hydrothermal vents and chemical soups resemble Earth's primordial conditions 4 billion years ago. Some hypothesize life began in such environments, with RNA-like molecules forming in chemical-rich settings, a theory supported by vent chemistry studies. Human impact, however, threatens this frontier. Plastic pollution, including microplastics in amphipod guts, has reached the Challenger deep. Over 8 million metric tons of plastic enter the oceans yearly, with 2019 samples showing bags and wrappers at 36,000 feet. Deep-sea mining for rare minerals like cobalt and nickel, used in batteries, risks disrupting ecosystems we barely understand. A 2022 report warned mining could destroy microbial mats critical to the food web. With less than 5% of the trench mapped, we risk losing species before discovery. The Mariana Trench Marine National Monument, established in 2009, protects 95,000 square miles, but international waters complicate enforcement. Global treaties, like the UN's High Seas Treaty, aim to address this, but progress is slow. The trench also captivates culture. Films like The Meg imagine prehistoric creatures like megalodons surviving there, though no evidence supports this. Megalodons went extinct 3.6 million years ago. Its mystique drives science and storytelling, making it a symbol of the unknown. The trench's allure has even inspired art, with exhibits like the 2024 Abyss installation in Tokyo showcasing its creatures. The Mariana Trench is Earth's ultimate enigma, a place where the impossible thrives. From the Trieste's heart-stopping dive to glowing creatures defying crushing depths, it challenges our understanding of life, geology, and exploration. We've mapped more of the moon than our oceans, yet each trench mission unveils wonders, new species, technologies, and threats. Will future dives unlock life-changing discoveries like cures from deep-sea enzymes or vanish under pollution and mining? The abyss holds secrets we're only beginning to touch, urging us to explore and protect it. Thanks for diving deep with me. If you loved this journey, smash that thumbs up, subscribe, and hit the bell for more adventures. In the comments, tell me, would you brave the Challenger deep, or is this one trip better watched from land? Keep exploring, and I'll see you in the next video.